Alright, so welcome back. In this video, we'll be considering what? Equation of a parallel line. Parallel line. So what is the equation of a line which passes through the point x1, y1 and parallel to what? Another line. Equation of a parallel line. So the equation of a line which passes through the point x1, y1 and parallel to another line. So with this, on our last videos, we treated what? Parallel lines. And we said that what? Parallel lines, they do have the same what? Gradient. So I drew the Cartesian plane, then I drew what? Two parallel lines. That means they are moving in the same what? Direction, right? They are having the same bearing, right? Alright, so we get two parallel lines and they are telling you to find for the equation of another. Giving the gradient or giving what? The equation of one line. Then it will give you a point. Then you have to note that they do have the same gradient. They do have the same gradient. Alright, so listen. Two or more lines are said to be parallel if they have the same what? Gradient. That is, if the gradient of a line is m, then the gradient of the line parallel to it is also what? M. If the gradient of that line is m, then that means they all have what? The same gradient. They all have the same gradient. So if this line has what? Gradient to be 3, the other line L2 will have what? The gradient to be also what? 3. Also, the equation of a straight line parallel to another line of gradient m passing through the points x1, y1 is found by making y the subject of the formula y minus y1 equals mx minus x1. So we'll be using what we treated on our last video recently now, equation of a line. So now let's see. Let's start with an example. Alright, so let's start with an example. They are asking now, what is the equation of the line parallel to the line? What is the equation? What is the equation of the line? So you can get the symbol for parallel, something like that. Parallel to the line. Parallel to the line. 2x plus 7y minus 8 equals 0, which passes through the point -1, 3. So what is the equation of the line parallel? So that's the symbol for parallel. To the what? To the line 2x plus 7y minus 8 equals 0, which passes through the point -1, 3. So they are asking you to find for the equation of the line which is parallel to this line, right? So now let's see how best we can solve that. So we have our first line which is L1, such that 2x plus 7y minus 8 equals what? 0, right? And they are telling you that that equation you are going to find, the supposed equation, passes through that point. So we can say that L2, we don't know that equation. So let's say ax plus by plus c equals 0. Now, this line, L2, passes through the point. So let's say this, let's k -1, 3 be the point in which that line L2 passes through. So the line L2 passes through this point k -1, 3. So how can we find for what? The equation of this line L2, which is parallel to L1. Now, if they are parallel, they move as in the same what? Direction, right? So they do have the same gradient, m1 here, then here also what? m1. So their gradients are equal. Or if here is m1, here also is what? m2. So I get m1 being equal to what? m2. They are the same. They are the same. So never mind at all. They are the same. Alright, so now let's see how we can solve that. So now, then, we know a point on the supposed line, right? We know a point on the supposed line. It's left with what? Gradient. Then, since they are parallel, we can find for the gradient of that line from this L1. So let's find for the gradient here. You can find for the gradient here. So now, if you want to find for the gradient, you have to express this line L1 as what? Y equals mx plus c, where m is the gradient. So if we have 2x plus 7y minus 8 equals 0, we can make y the subject. So I have 7y being equal to negative 2x plus what? 8. Then what? 7y on 7 equals negative 2 on 7x plus 8 on 7. So we can say that y being equal to negative 2 on 7x plus 8 on what? 7. So we can say that m is equal to a negative 2 on 7. That's our gradient. That's our gradient. So we can determine our gradient from this line because they are parallel. If they are not parallel, please don't assume that your gradient will be here. No. We don't do things like that here. So if they are parallel, if and only if they are parallel, we take the gradient from the other line, which is L1, to help this guy get what? The equation of that line, right? So now let's move on. So we know since they are parallel, they have the same gradient, so I can say that m is also equal to a negative 2 on 7, right? Then we can use the point k and this gradient to find for the equation of the line, which is y minus y1 equals m x minus x1. We can use our formula. So here is x1, here is y1. So y minus y1 is saying 3 equals m, which is negative 2 on 7. Then x minus x1 is what? Negative 1. So I have y minus 3 equals negative 2 on 7. Then x, then plus what? 1. Right. So now we can multiply through by 7. So 7 times y. Or you can multiply here, you can multiply there, then you go y minus 3 equals negative 2 on 7x, then minus 2 on 7. Because negative 2 on 7 times 1, now we get negative 2 on 7, right? Then y being equal to a negative 2 on 7x minus 2 on 7. I group minus 3 crosses, I get plus 3. Then I'll get y being equal to negative 2 on 7x. Then now here, 7 times 3, 7, 3, which I'll get 21. So I'll get minus 2 plus 21 on 7, right? So y being equal to negative 2 on 7x. Then minus 2 plus 21, I get 19. So I get which is positive 19 on what? 7. Positive 19 on 7. So the supposed equation, the equation of L2. So therefore, L2, which is parallel to this guy, is what? L2 is negative 2 on 7. Negative 2 on 7, x plus 19 on 7. So kindly watch it carefully. Very, very simple. Alright, so let's see another example. So let's see another example. Okay, let's watch this question. So this is a course book from our very own lecturer, Dr. Stephen Edward Moore. Our very own lecturer, Dr. Stephen Edward Moore. So that's lecture notes on what? Analytic geometry and calculus. Very, very good. Very, very good. Very, very good. We appreciate you, lecturer. Thank you very much. All right. So, Dr. Stephen Moore, so you can get your copy at the University of Cape Coast Department of Mathematics, right? And you get your copy. Very, very simple. I think we bought it. Is it 30 Ghana or was it 25 Ghana? Yeah, I've forgotten the price. So, you can get your own copy. If and only if some is available for you. Right. Okay, so let's start. Given the line L, given the line L with equation ax plus by plus c being equal to 0 and the point P x1 y1 full stop. It says show that the line through P parallel to L is given by ax plus by equals ax1 minus ay1. So now, given the line L, we are given the line L with equation ax plus by plus c equals 0 and the point P x1 y1. Show that the line through P parallel to L is given by ax plus by equals ax1 minus ay1. So now how best can we solve this? So given the line L with equation, so that means the line L has what? Equation ax plus by plus c being equal to what? 0. And the point P, that's what? x1 what? y1. Right. Show that the line through P parallel to L is given by that. So now, let's see how we can solve that. If it is parallel to that, then we have to find our gradient from this line, right? Okay, so let's find for the gradient. So I have to express that in the form y equals mx plus c, right? So now I have ax plus by plus c being equal to 0. I can make y the subject, so by equals negative ax negative what? C, right? So now by on b equals negative ax on b, then minus c on b. So I can say that y being equal to negative a on b, x minus c on b. Right. So now we have our gradient. Our gradient is what? Negative a on b. Since they are parallel, I can use the same gradient. So I have my point, which is p x1 y1. So I have my general formula for finding the equation of a line, which is y minus y1 equals mx minus x1. So my y, I don't put any value inside, y minus y1. I know that is still what? y1 equals m, which is what? Negative a on b. Then x minus my x1, which is what? My x1, which is the same thing as x1. So I have my y minus y1 equals negative a on b what? X. Then plus a on b x1. So I multiply through by what? Negative a on what? B. Right. So now they say show that the line through P parallel to L is given by that. So they said we should show that that's the line which is parallel to that. So now let's see whether we can get that. So let's multiply through by B because the LCM is B. So I get by minus by1 equals what? Negative ax then plus what? ax1. Right. So now let's see what is here. Here is what? Ax plus by. So now let's see. We have negative ax. We have to send it. Then we get what? Positive ax. Right. Then here is plus by. So that's it. Plus by. Then being equal to, that's ax1. So ax1. right? Then minus ay1. So here is supposed to be what? Minus ay1. It's supposed to be b, not a. That's a mistake. It's supposed to be b. So minus by1. So that means this one must cross, then I'll get what? My plus by1. It's supposed to be plus, sorry. It's supposed to be plus. So that means that's a typographical distance, right? A type, that's a type. Sorry for that. So that means they said, show that the line through P parallel to L is given by what? AX plus BY equals AX1 plus what? BY1, not minus BY1. Because when you are solving, you will not get that. So this one crosses the equal sign, which will be what? Positive. And it's what? BY1 is BY1. Because the LCM is what? B. And when you multiply through by B, you get BY1 equals what? Here will be what? Negative AX. Because this denominator will cancel the LCM, which is BB. Then negative AX plus what? This one to cancel, then I'll get AX1. Then I have to make sure that this looks the same thing as that, right? So negative AX crosses, then I get what? Positive AX. Then plus BY equals, I have my AX1, which is that, AX1. Then this one is a problem. So it's supposed to be what? Plus by1, not negative ay1, sorry. So minus by1, when it crosses, I'll get plus by1. So now, when we are done, then write hence. When you are done, then write as required. As required. As required. Because he said you should show that. So when you are done, then you write ax plus by equals ax1 plus by1 as required. So we are done. So kindly watch it carefully.